You'll get recorded. Rolling. It's Wednesday, February 11th. We're moving on to 9-2. So adding and subtracting rational expressions, right, which are these fraction-looking expressions. Okay. And then you guys know well it's 9-1, 9-2 is open. We covered 9-1 yesterday. We're covering 9-2 today. Okay, so guys will have a few days to do that. Yep. Try it. All right. Here's top mathematicians for Module 8. So awesome job. Team made the list.
Up there, baby.
There's still a few more students who have to take a quiz. I have not. All right. So on your paper, write your name. Everybody just put their name on the paper. And this says 9-2 notes. We're doing 9-2. Yeah.
Quiz correction.
Okay, guys, everybody's got to take a quiz first. After everybody takes a quiz, then I can give the quiz back to you guys, and then you can do a quiz correction. Let's do it. This method's been working out pretty good because then you guys were paying attention and taking notes, and that's been, I think, pretty helpful. Tomorrow will be an Alex Day, and Friday will be an Alex Day.
I'm so glad that neither of us have dropped them. We can just be put together.
Right. All right. So, well, when I was in high school, we had to do them all at home. So, is that? Right. So this has to do with adding fractions together, adding subtracting. Guys, what if you have 1/3 of something plus 1/2 of something? Okay, and to give you guys a visual, suppose you had a pizza and you cut that in 3 slices. So you had another pizza. You cut that in half. Okay. And we're going to take this big 1/3 slice and this big 1/2 slice and add those together. Okay. So these pizza slices represent these fractions. So what is that? Hey guys, how do you add fractions together? You have to have a what? Common denominator. Here, I'll write that over here. Common denominator.
Wait, is this on note?
Yeah, this is your notes. Okay, so everybody's taking these notes. You write your name. You're at 9-2 notes. Okay.
Punish me.
So I'm gonna do a few examples with you guys. Then you guys turn these in and get points. We've been doing it for a while. Okay, so guys, what's the common denominator going to be? Yeah, it will be 6. Okay, and no, the number 3 and the number 2 are prime numbers. Okay, kind of thinking ahead. Yeah, later. Okay. So this 3 needs the 2 and the 2 needs the 3. So I'm going to multiply top and bottom by whatever what. 2 over 2. And multiply the 1/2 by 3 over 3.
Yeah, so
is that true? Okay. Now, that's kind of the theory of why this is okay to do, why this works. What is 2 over 2 itself equal to? 1. And same thing, 3 over 3, it's equal to 1. Okay. So guys, can you multiply any number by 1 and you haven't changed anything mathematically? Okay. What we are doing is we're getting a common denominator. So this is the same thing as 2 over 6 plus 3 over 6. Okay. And altogether, what would the answer be?
5 over 6.
5 over 6.
Yep.
There you go. Okay. Alright, so say go back to my pizza slices to finish the visual. If I take this half, okay, and I combine it with this third, maybe that could go about like this. Okay. Now, what I have altogether is like 5/6 of a pizza. Right, is it? Alright, let's do another warm-up example. Oh, okay. Everybody got that?
Yeah.
Yes.
Alright, so second warm-up example. Let's do 1 over 12, and then I'm going to leave a little space like I did before, plus 1 over 18. 1/12 plus 1 over 18. Okay. And to give you guys a visual again, let's say I have a couple of pizzas.
Pizza.
I'm gonna slice one into 12 slices.
Oh, good.
Okay. And then 1/12 could be just one of those slices. Okay. And 18 looks more like.
You go to the Target near here on Wickham. On Wickham.
There's 18 slices. Alright, so a single slice might be like that. Okay. So what is that wedge plus that wedge?
I have
Okay,
what's it called? I have a friend that works there.
Okay,
So
now-
he gave us one for free.
You guys were just telling me to add fractions together. You do need a common
Yeah.
denominator. And the way we found the common denominator before is we said, well, we could multiply each fraction top and bottom by the other guy's denominator, and that worked. Which you could do, guys, you could do, but then for this particular example, you would end up having to simplify at the end. So there's another way to do it. I'm gonna add to this term common denominator. I'm gonna say least common denominator. So you could do 12 times 18 and work it that way, but there's a smaller number that both 12 and 18 go into. There's a smaller number. Okay. And the way you can find that number is you can do a prime factorization of each of 12 and 18. So the number 12, the number 18. Guys, 12 breaks down into what times what times what?
6 times 2.
Yeah, 6 times 2. And then 6 further breaks down to 2 times 3. So let's go 2 times 2 times 3. That could multiply up to 12. How about 18? Guys, what 18 breaks down to what prime factors?
9 to 3, 3 and 2.
Yeah, so 9 and 2, and then 9 becomes 3 and 3. So let's go 2 and 3 and 3. So that could multiply together to create 18. Okay. And the idea here is this 12 and this 18 have some factors already in common. Like they each have a 2 already, and they each have a 3 already. Okay. But what this 12 lacks is what? Yeah, it needs another 3. So I'm going to multiply this guy top and bottom by 3 over 3. Okay. And what does this 18 lack? Yeah, it needs another 2. So I'm going to multiply top and bottom by 2 over 2. Okay. So this will result in a common denominator, but it'll be a least common denominator, so it'll be already simplified going forward, and then you'll have to simplify at the end. Okay? That's kind of the idea. Okay. Alright, so how's this work out? Here, guys, everybody write this down.
Oh, yes.
Alright, so this is 3 out of 36 plus 2 out of 36. And yeah, 5 out of 36,
So mad.
which game is already simplified because we went through the least common denominator. It's called LCD.
What are you doing?
See that?
You broke my tip.
Bro.
And that's it. 5 out of 36.
Did you grab my tip?
You're actually.
You literally came up to me and grabbed my tip. Just like we over.
Alright. Okay, you guys get there? Okay. So that was just a couple of warm-up examples. Those aren't even out of the book. I just want to remind you guys how to add fractions together. But now let's switch over to the book. In the book. Okay, so here, this is on page 125 if you like, 92. Right, so I did already record a longer video that covers all the examples at the beginning, and then anything that's green highlighted here, green highlight, okay, covered all these. So I'm gonna do with you guys number, let's do this 28 right here, 28.
And Boucher.
So number 28 out of your book.
Hey.
Okay, I got
Come here.
8 divided by 3y. Okay. Then leave some space so you get a common denominator. Let's do plus 2 over 9. And then leave some space. And we'll do, oh, sorry, this is negative. So minus 3 over 10y squared.
You don't know what you're doing.
All right. So I'm gonna get it from that last example. Help you out. Oh, this 3y right here needs. What should I multiply top and bottom so that I can? What should make a common denominator with these other fractions? Yeah, it needs another y. That's true because I do see a y squared here. So I'm gonna have to get a y. What else? Yeah, another 3 because 3 times 3 would bring you up to this time. So yeah, I do need a 3. Okay. And also, guys, what about this 10? Better have the full 10, right? So 3 and 10 can be 30. So let's multiply top and bottom by 30y. Like that.
Makes me angry.
That's the first one.
Almost make me as mad as people when they say they don't.
Okay.
That's it.
How about this one right here?
Thank you for it. I think that big kill.
Right.
Tell Jorge if he ever needs his headlights done.
Well, here, guys, let's look at what I got from this fraction. Let's start to trick fractions. That could be helpful too. Something plus something plus something. Okay. Here, guys, what is this common denominator that we're constructing? 30. You guys see it's going to be 90y squared, right? Because 3 times 30 is 90, and then y times y is y squared. Okay. Now here I have 240y. Okay, like that is that.
You want my
That's a carrot. Here, guys, here, sit down, look here, take notes. Look.
Bathroom.
Right, so this next fraction, there's already a 9, so what else do you need to bring it up to the same denominator? 10y squared. Then multiply top and bottom. Again, the theory is that p right there is equal to 1. That's not really changing.
No.
So I got the same denominator, 90y squared before. Okay. And what's in the numerator now? 20y squared? Took that? Oh, I forgot to make this last one negative again. There you go. This last one's going to be negative. Okay, so I have 10y squared. I need 90y squared. So I need to multiply top and bottom by what? Yeah, 9 over 9. There you go. So the top is negative 27, and then bottom is 90y squared. Yeah. Okay, guys, question here. Look at this middle fraction. Can you cancel out the y squared or y squared?
Yes.
Okay. Okay, you could, but why do you not want to do that? Yeah, then you're just working backwards. You're just going back to 2 over 9. Okay. What we're trying to do, the reason I did all this pinking right here is because I'm trying to get a denominator that's common to all 3 fractions. So we're gonna leave that with that. Okay. Now we can add these together. I got a 20y squared term. I got a plus 240y. Whoops.
Yeah,
240y. I got a minus 27. This is all divided by 90y squared. Okay. Now, it's possible that numerator factors may but whether it does or not, it will really simplify anyway. It's not, nothing's going to cancel with the denominator at this point. So, I'll just stop right there. Thank you.
What if they're good guys? Please.
Yeah, that's the answer.
It's pretty hard on. Because I have to watch.
Yeah, that's how we're doing. Right, so next example. Oh, yeah.
Your family, they don't gotta like. Okay, I'm being.
Alright, you guys have that? Alright, let's go over here to number 44. We're gonna copy this out of the book. Number 44. 44. Alright, so I got 2 divided by a minus 1. Then leave some space. Let's do a plus. And then 3 divided by a minus 4. Yeah, A. We're working with A. It's like X. Your book just went with A, so. Okay. Yeah, that's an A. That's an A. Then this is all divided by
I know.
6 over
We're dividing the fraction.
A squared. Yeah, we have a fractions within fractions. Minus 5A plus 4.
Wait, I think I see this. No, never mind.
Yeah, guys, I want to pick one that had some complexity to it, so that when you guys get Alex questions, if they're easier, you can definitely do them, and if they're this difficult, you guys got a good model too.
I'll just give you back.
All right.
No.
Okay, so at the top here, this denominator is a minus 1. This one's a minus 4. Guess what the common denominator is going to be? Yeah, a minus 1 times a minus 4. So I'm going to multiply this left fraction. Here, guys, everybody focus here. Focus here. Where's your notes?
He took my
I'm just getting what I missed from when I went back.
A minus 4. A minus 4. And this one over here, I'm going to multiply top and bottom. A minus 1 over a minus 1. Okay. And everything in pink just simplifies to 1. That's equal to 1. That's equal to 1. Okay, so that's a valid step to do that.
What WTF today? What's the news? Sleep.
Right.
I gotta work.
Oh. Let's do 2
I don't understand like the outside.
A minus 4.
Like you should watch out for this.
And this is all divided by
Just for like
Okay.
a discipline.
A minus 1.
Like
A minus 4. Okay. So I'll do plus 3 times
That's what I'll call
this A minus 1.
We're going back and just look at all the headlights that possible.
Now, since these top two fractions have now a common denominator, I just went ahead and pushed them together to giant fraction.
And then I'm gonna
You
bring
have to say multiply by multiply.
Yep.
Make shit. Business card.
Guys, what am I gonna write over here?
Put them on the windshield.
Exactly. You guys see if you divide by a fraction, can you take that bottom fraction and flip and multiply it, like reciprocal type? So this will be a squared minus 5a plus 4 flips up to the top. Here, Joe, that's stop. What's that?
Just punish me.
And then divide by 6 down here. Okay, so now it looks like that. One of the next things you're gonna do is distribute this 2 and then also distribute this 3.
I like those.
Oh, yeah, but I had to do this somewhere.
No.
It's back here.
You are, I think you're going to the old. Yep, definitely.
Is this the same problem or a new one?
Yes, same question. Continue.
Actually.
Now, something else I want to do. Guys, look at this quadratic looking piece on the upper right side. Does that look like it probably wants to be factored?
That's just.
Here, guys, how does this factor on the top right?
You know how many rounds in hand?
Guys, focus here,
Do it.
Guys, look up here.
I think you'd actually do it.
What are two numbers that multiply to 4 and add to negative 5?
Yeah.
$3.
8194. A minus 1, A minus 4. Hey, let me show you. So you can boil. Guys, here, stop throwing house. Look up here. Guys, everybody, just sit. Guys, everybody, sit down. Look up here. Focus. Take notes. Think deeply about this. Right. And then this will really help you out when you get the same type Alex questions. Right. So A times A. Well, let's do FOIL. Well, A times A squared. Bing. Outside negative 4A. Inside negative A. Put that together. That makes negative 5A. Bing. Last. What's negative 1 times negative 4? Positive 4. Bing. So that's the same thing as that. Now what?
Where did you get 5A?
Is this in a birthday?
Oh, I see.
That's the answer.
You didn't. I had a room on my grade 30 more.
That's when they're. And like. You're right, without the priority too. And you know, I know that, I feel like it's the unconscious, like, I'm so far away.
Hey, you guys got that in your nuts?
Got it.
I know
that.
someone
Got that?
steal my penis.
And nobody thinks that.
Huh? You're what? Okay, need more paper? Need more paper. Yeah, we're gonna do another. Here, stick that here. Alright, so, alright guys, there's a couple of physics questions in here. One of them I just want to point out. Guess this one, we're standing in front of this lens and whatnot. Okay. Now, if you're in class, you guys probably did this with the parabolic mirrors. Yeah. Alright, so there's a little pop pick here. If you get the right angle, it kind of gets to work on camera.
I'm taking
Let's
it now.
see. Hold on.
What are you doing with your problems?
Crush it.
baby. Crush.
Usually I can get it to work on camera.
Oh, I saw it.
It's right here.
I crushed my problem.
Flash, bro.
I pee in cups.
Okay. Yeah, you can kind of see it popping up
Yeah,
over
I
here.
see it.
And I fly over the lake.
Right. It works really good in person. And so the formula that goes with this is the exact same as number 36. That one I covered in a longer video, so if you want to do the math behind that. But I'm gonna do one more with you guys in class though. And it's a different physics question. Guys, look up here, You know what's going on? It's number 58, electronics. They talk about resistors in series. Alright, so number 58, we're doing number 58. Resistors in series. Okay. Now, what does that mean? Resistors, or sorry, in parallel is what I meant to say. Here, I'll draw both of them for you guys. Let's do resistors and series and resistors and parallel.
I'd be scared to be two-sided.
So in series, you create a circuit that looks like this.
We just like get in a like with them.
These two lines represent the battery, and these jagged looking lines are resistors. For example, light bulbs. Right, so if you have a string of Christmas lights, you think of that way. Okay. But there's another way you can wire up those resistors to the battery. Right, so here's the battery again. Okay. What if instead I wire these up like this? Okay. And now the physics is different. Like here, guys, look up here. Think about this.
We're talking about my tip.
No, we're not. We're talking about this. We're talking about resistors. Okay. So from the point of view of the battery, the resistance is completely different in both of these cases. In the left case in series, you add them up. And in the case on the right, you follow the equation from the book. And the book says, in parallel, the total resistance, R sub T. So I'm copying this straight out of the book. It says it's 1 over R1, leave some space, plus 1 over R2, leave some space, plus 1 over R3. Okay, this is all one giant fraction.
Can you punish me? Or...
punishing, bro. It's good.
You take my physics class, you'll see this in also a little bit different form too, but it'd be consistent with this. Right, and your book wants you to simplify this. I mean, we got fractions within fractions. There's probably a prettier way to write this. And so, you guys, these resistors work could be anything. Maybe it could be like 5 ohms and 10 ohms and 28 ohms. The numbers can be anything. Okay. So these are all completely different. We're going to solve this in terms of variables. I think this first fraction needs
There's a thing called
the R2 and the R3.
Gmail.
Gotta multiply top and bottom. R2 over R2. R3 over R3.
Except
The second fraction needs the R1 and the R3. R1 over R1. R3 over R3.
It's like a straight.
This last fraction needs the
Should I not be
R1 over R1.
Like, no, why would you
R2 over R2.
I don't know. I was looking
Okay.
I was looking for Jay-Z.
And that will give a common denominator.
Media.
So now the total resistance is. Okay, so we still have 1 over. And this is. Okay. Well, since they have a common denominator, I'll just go ahead and write that in here. R1, R2, R3. This is R2, R3. Plus, this is R1, R3. Plus, this is R1, R2.
Yes, please.
So look like that.
Any water, please.
No, this is my.
We actually need to practice and I'm trying to.
I didn't know that my third bottle today. My second bottle today.
Is that the answer?
Wait.
Almost. There's one more thing you could do, which is what?
Hold it there.
Oh,
Yeah. 1 over this fraction, you can just pick the bottom fraction and flip it. Yeah, you did it. And that's the last thing I'll do you guys here.
Alright.
So the total resistance is R1, R2, R3 over.
You've got all day to drink that
I have eaten in every single class today. Bro, it's so
I
bad.
probably had like a water bottle every single class, and I've lost my water bottle a month. But it's a plastic one, probably.
Hey, so
Is this the last one?
yeah. Okay, so it's a pretty comprehensive set of examples there. Guys, double check, make sure your name is on your notes. Turn those into the grade tray. I'll give you guys points for your notes.
Alrighty.